You are sitting on a flight from Dubai to London. Outside there is nothing. No landmarks, no roads, no signs. Just ocean and sky. And yet the aircraft knows exactly where it is, down to the meter, at all times. I am a licensed aircraft maintenance engineer. I have worked on the systems that make this possible. And what most passengers never realize is this. The aircraft does not navigate by looking outside. It navigates by feeling itself move. For most of aviation history, navigation was guesswork. Pilots used dead reckoning. They took a known position, applied their speed and heading, and calculated where they should be. It worked, mostly, but errors accumulated, over hours, over oceans, over mountains. Early North Atlantic crossings regularly saw aircraft arrive miles from their intended position. Not through negligence, through the limits of dead reckoning across featureless ocean. There were no landmarks to cross-check against, no ground stations in range, just accumulated error, growing silently for hours. The industry needed something fundamentally better. The answer was inertial navigation, the Inertial Reference System, the IRS. It does not need GPS, it does not need radio signals, it needs only one thing, a starting point. At the gate before every flight, the crew enters the aircraft's position manually. Latitude and longitude, exact. From that moment, the IRS takes over. Inside the system are accelerometers and gyroscopes. They measure every movement, every acceleration, every turn. The system integrates those measurements continuously. It calculates position in real time, always, silently. No GPS required. No ground contact required, just physics. Modern aircraft do carry GPS, but GPS alone is not enough. For precision approaches, for oceanic flight, for Category 3 landings and near-zero visibility, a single source is a liability. So the aircraft uses multiple systems simultaneously. IRS, GPS, VOR, DME, ILS on approach. Each one provides a position solution. The FMS compares them. It validates, it selects the best solution. If one source disagrees, the FMS identifies the outlier and removes it. The aircraft is always navigating from a verified position. The flight management system is the brain of navigation. Before departure, the crew loads the entire route. Waypoints, airways, altitudes, speed restrictions, fuel calculations. The FMS holds all of it. In the air, the FMS manages the autopilot. It sequences waypoints. It calculates required track corrections. It adjusts for wind. The crew does not hand fly across the ocean. They monitor, they verify, they intervene when required. But the FMS is flying the route. In 2008, Qantas Flight 72 was cruising over the Indian Ocean when a faulty sensor fed incorrect data to the flight computers. The aircraft pitched sharply, twice, without crew input. 110 people were injured. Even during a major system fault, navigation never failed. The IRS continued to provide valid position data throughout the entire event. The investigation found a fault in the Air Data Inertial Reference Unit, not in navigation itself. The systems were doing exactly what they were designed to do, detecting the fault, isolating it, continuing with valid data. Multiple redundant systems meant the aircraft always knew where it was. Now let me tell you what we check on the ground. Before every flight, the IRS alignment is verified. It takes approximately 10 minutes at the gate. The system self-aligns using gravity and the Earth's rotation. During that time, the aircraft cannot move. If it moves, the alignment is invalid and the process restarts. After alignment, the position displayed by the IRS is cross-checked against the entered coordinates. If the discrepancy exceeds limits, the system is grounded. The FMS database is also checked. Navigation charts and waypoints have an expiry cycle, 28 days. If the database is out of date, the aircraft does not fly. The navigation data is as controlled as the airframe itself. You assumed the pilots were navigating. They are not. The aircraft is navigating. The pilots are verifying. That distinction matters because the system is more precise, more consistent, and more resilient than any human navigator could be. It never drifts, it never fatigues, it never guesses. An aircraft crossing an ocean is using 3 independent navigation systems simultaneously. each one providing a position solution, each one being cross-checked against the others. That is not redundancy for comfort. That is redundancy for certification. The IRS requires no external signal. The FMS requires no human input once the route is loaded. The navigation database expires every 28 days and is replaced before every cycle. Nothing in this system runs on assumption. Every time that aircraft takes off, it knows exactly where it is, and it will know exactly where it is all the way to the gate. The aircraft always knows. The aircraft always knows. If you want to understand what's actually happening every time you fly, subscribe. See you in the next one.